Morning, guys. This is going to be the last video lesson I'm going to do. If I do any more, just be test corrections, and hopefully that will happen. So you need to open your book up to page 739, rotations. There is a lesson on dilations. I'm not going to do a video on dilations. I'm going to make that an optional lesson. I'll put the information on Google Classroom, what to do there. You don't have to do it. There is no penalty for not doing it. Primarily it's there for some people who like to know about dilations, and for those who are going on to higher level math and you like to make sure you've completed things. So there'll be an optional lesson there with an optional assignment. So 13-7 is on rotations. Rotation, of course, that's what you learned earlier in your career as a turn, all right? So it's another type of transformation. It's also a congruence transformation or an isometry. You keep the same size and all that. So you see on page 739, it shows you like windmills. We're familiar with windmills. This is windmill country out here. Lots of windmills. And so that's basically, so a rotation has to have a center of rotation. You have to rotate around something. Okay? So a rotation, you remember, a translation is a composite of two reflections over parallel lines. Well, at the bottom of page 739, you can see, you might want to put this in your notes. A rotation is a composite of two reflections over two intersecting lines. Okay, remember, for note purposes, you can stop anywhere you want to put things in your notes, okay? All right, look on page 740, example 1 says, find the rotation image of rhombus ABCD over lines M and N using reflections, okay? So basically what you do is you have rhombus ABCD, you see that in the picture, the first thing you do is you reflect it over line M, okay? So you do a reflection of line M, that would be a rhombus A prime, B prime, C prime, D prime, all right? Then you take that image and reflect that over line N, and that gives you rhombus A double prime, B double prime, C double prime, D double prime, and so that would be your rotation from rhombus ABCD. So basically two ways that a rotation can be performed. You can do it just like we did. You can do it as a composite of two successive reflections over two intersecting lines. They give you an example there halfway down the page, or you can do it in terms of an angle of rotation, which obviously requires some center point. You have to be rotating around some center of rotation, and then you can just do a thing. This is where you could use your protractor. Obviously, you may or may not have a protractor at home. I'm going to make that part of the assignment optional. All right, so then it has postulate 13-1. So you need to copy this into your notes, okay? And I will, obviously you can pause and do it. I'll read it, you can pause and get it down. In a given rotation, if point A is a pre-image and point P is the image and point W is the center of rotation, then the measure of the angle of rotation, that would be angle AWP, is twice the measure of the angle formed by the intersecting lines of reflection. So your two lines that you're reflecting over intersect, they create an angle. Your angle of rotation is going to be twice the angle formed by the lines of reflection. Look at example 2 to see what I'm talking about. Example 2, bottom of the page, says find the rotation of segment XY over intersecting lines L and M, which form a 40-degree angle by using the angle of rotation. Since the angle is formed by line L, measures 40 degrees, and the angle of rotation will be twice 40 degrees or 80 degrees. And that's how you would do that, okay? All right, and then example 3 basically says triangle XYZ is rotated 180 degrees in the coordinate plane to form triangle X prime, Y prime, Z prime. Make a table of coordinates of the vertices. Use a table to find a pattern. Well, it turns out that when we do 180-degree rotation, then basically the image, if you do a 180-degree rotation, then basically all you do is do the opposite. So if point P has the coordinates X and Y, then the image would have the coordinates opposite of X and opposite of Y. All right, so that takes us to the assignment. So get your papers ready for the assignment. All right, you should be ready now. So this is homework number 18. Homework number 18, which could be your last homework assignment. Homework number 18 is on pages 743, 744, And is problems 15 through 30, except that there will be a couple of optional problems in there, 15 through 30. So, and this will be written in Google Classroom as well. So homework number 18, problem numbers 15 through 30, pages 743, 744. All right, so get your papers ready. We'll do this. I'll bring the board out when we're ready for the board. We're not quite ready yet. All right. Look at 15 and 16. It says, for each of the following, determine whether the indicated composition of reflections is a rotation. Explain your answer. And the answer is going to be based on the definition, okay? So if we look at 15, then triangle ABC is reflected over line N. So the blue is reflected to the green, and then the green is reflected over line T to make the red or the pink. So therefore, yes. So you would write, and again, you can go to the back of the book, look at 15. The answer to 15 is what you will copy. 15 is yes, it is a proper successive reflection with respect to two intersecting lines. So no reason for me to write that on the board or repeat that. Just go to the back of the book, look up the answer, number 15, and copy what it says. And then pause however long you need the video before you continue. All right, 16, same thing. Look at 16. The blue is triangle ABC is reflected over line N to make the green image, and then the green image is reflected over line T to make the red or pink image. So same answer as you had before. 15, 16 have the same answer. Yes, it is a proper reflection, a proper successive reflection with respect to two intersecting lines. All right, that's 15 and 16. All right. Again, pause, whatever you need to do to get done. All right, 17, 18, 19 says two lines intersect to form an angle with the following measure. Find the angle of rotation for each. If you remember what you wrote in your notes was that the angle of rotation is twice the angle formed by the two intersecting lines. So what you showed me, 17 says 55 degrees. So on your paper, write 55 times 2 equals, and that should be 110 degrees. 18 is 28.5. So on your paper, write 28.5 times 2 equals, and that equals 57. And then 19 is 74 degrees. So you write 74 times 2 equals, that's 148. All right, here's where your work comes in, okay? All right, 20 through 22 says, copy each figure, then use a composite of reflections to find the rotation image with respect to lines L and T. So what I expect to see is basically you copy the line, and I expect to see three figures, your original figure, and then you reflect that over the first lines. So draw that to best of your ability, and then reflect that over the second line. So you just give me your best work possible in 20, 21, and 22. All right, 23 through 25. Here's what you're going to do here. Here's where some of this is a kind of optional case. So copy each figure and use the angle of rotation to find the rotation image. Well, they give you the image there. What I expect to see on these is just show me 23, show me 2 times 50 equals 100, and then give me an image that looks like it's a little bit over a 9-degree rotation. Just your best shot. Don't worry about it, okay? 24 is 9 degrees. 2 times 9 degrees is 180. So give me what looks like a 180-degree rotation. And then 25 is 30. So show me 2 times 30 equals 60. Show me your work. And then draw an image that looks like it's about 6 degrees. Just give me your best shot, okay? Look in the back, see if they got pictures for 23 and 25. If you haven't figured this out by now where pictures are involved, they do not give you the answer to every odd problem. So again, don't worry about this. Just give me your best shot. I'll give you credit, okay? If I drop too many problems, then the problems become worth more and it costs you more points if you leave things out. So the more problems, the less they count. All right, 26 and 27 are totally optional. It says in the following figures, a rotation of triangle ABC has been performed with respect to lines P and Q. Use a protractor to find the angle of rotation. So if you have a protractor, then you can do 26 and 27. If you don't, then they're optional. Just write optional for 26 and 27. Otherwise, you can do it and get a little extra credit, okay? All right, last part, 28 through 30. Look on the next page, says copy and complete the table below. Determine whether each translation preserves a given property. Write yes or no. So I need to see you on your paper, copy the whole thing, copy the table. I need to see all the lines, all the blocks. This is an easy way to get points here. So just copy the table. And then basically you write on the left, 28, 29, 30, that's reflection, translation, rotation. And then across the top, you have angle measure, between the points, orientation, collinearity, distance measure. All right, pause the video and copy that table onto your paper, and then we'll fill it in together, okay? So copy the table. Again, guys, don't throw away points by not copying the table. That's too easy a way to get points, okay? All right, by now, you should have paused. You should have had your table and you're ready to go. All right, the key here is a reflection, a translation, and a rotation are all congruous transformations. They're all isometries. Therefore, they preserve, the term we use, angular measure, between the subpoints, collinearity, and distance measure. Therefore, for all of these, angle measure should be yes, yes, yes. Between the subpoints should be all yeses. Collinearity should be all yeses. Distance measure should be all yeses. Now, orientation is different, okay? A reflection obviously does not preserve orientation. That'd be a no. A translation, since it's only moving right, left, up, or down, does look the same, and therefore the orientation is yes. With a rotation, obviously, it's no, okay? All right, so that should be a really simple, easy 100 or 100 plus if you choose to do the extra part of the video, okay? All right, so this is the last official lesson. All these lessons are going to be posted, and I will post the last lesson as a choice. All right, have fun. Contact with me any questions.